Hi, I'm Jesse Dringoli with Bentley Systems, and today I'm going to show you how the PondMaker tool in CivilStorm, SewerGEMS, and PondPack can greatly speed up the process of designing a detention pond. So today we're going to take a look at a small 3-acre site with the pre- and post-network already set up, with the objective being to design a detention pond to reduce the peak outflow of the site to below the pre-development peak. So in this case, the post-development network already has the pond and outlet elements in place, but the pond dimensions and the outlet components are not yet designed. So let's take a look at PondMaker. You can right-click on the pond, Design Pond with PondMaker. So first I'm going to set up all the design scenarios. We're going to look at a 10, 50, and 100-year event. And we're going to establish the target pre-development rates based on pre-development scenarios. So I'm going to select all the respective scenarios. And we're going to pull the pre-development target from the site outfall. So computing step 1 allows us to take a look at all the target peak outflows and the post-development peak inflow rates. So next I'm going to estimate the storage required for the pond. I'm going to use the upper boundary method for a conservative estimate, and that populates the worksheet at the bottom with the estimated storage. So next I'm going to design the pond to hold that estimated storage. In this case we know the depth, but we want to calculate the area. So we know the pond is 5 feet deep. We'll enter a depth of 4.5 feet, 1-to-1 side slopes, a freeboard of 1/2 foot, and we know the top of the pond is at 100 feet. So this will allow it to compute the area accordingly. And I'm going to compute step 3, which will place the estimated storage into that pond. And let's adjust the freeboard option so that we can see that the estimated freeboard depth is passed. So next I'm going to design the outlet structure to attenuate that flow. And I'm going to choose to have an orifice and a riser. So let's place the orifice at the bottom of the pond, and we'll start with 6-inch diameter. This will capture the 10-year event rainfall runoff. And the riser, we'll put that up a little bit towards the top of the pond, and we'll say a foot diameter and enter some typical coefficients. And let's compute the rating curve. So here, the target is to get your rating curve as close as possible to this target rating curve so that you achieve the goal of attenuating the flow down to the pre-development rates while still maintaining that freeboard of 1/2 foot. So we can see here we need to increase the diameter of the orifice quite a bit. So let's bring it up to, let's say, 8 inches. And that gets us a little bit closer. Now let's raise the riser up a little bit as far as the diameter, and we'll bring it down to, let's say, 97.5 feet. Let's try that out. Okay, so that gets us much closer. So we're pretty happy with this, so I'm going to choose that and commit that to the worksheet, and that will populate those values. So now that we have a design pond and outlet, let's move on to the routing step where we can actually commit that pond and outlet to the model and have it route actual flows through it to see if we've gotten close to our design. So previous to this, it's just been estimates. So we did pretty well, but we need to make a few adjustments here. So let's bring the riser down a little bit. So let's change it to, let's say, 96.5. And that gets us pretty close. But the one thing I noticed is that our maximum water surface elevations are now quite a bit lower than the top. So our pond is basically a little bit oversized, and that's mainly because we chose the conservative upper boundary estimate for storage estimates. So let's go ahead and try reducing the pond size by, let's say, 75%. So we'll multiply that by 0.75. And let's try it again. Okay, that's pretty good, but let's make one last tweak here. We'll move this riser up to, say, 97.5 again and see how that works. Okay, so we're pretty happy with this design here, so I'm going to go ahead and commit that to the model. So now let's take a look at the pre and post 100-year event and do a little comparison to show you the effect of our design pond. So here we can see that the light blue or the cyan line here was our pre-development peak flow, and the red line is our post-development flow, and the green line is what we attenuated that post-development flow down to, and we can see it's below the pre-development target, and our pond did not get up to the required freeboards, so everything looks pretty good. So as you can see, PondMaker is a pretty powerful tool, lets you design your pond very quickly, and I hope you found this video useful. Thank you for your time.